In this video, we are going to create an algorithm called prime number, which takes one input called a of type integer and returns true if the input a is a prime number. Otherwise, it returns false. We define a prime number is a number which is divisible only by 1 or itself. We do not include 1 as a prime number. For instance, 2 is a prime number because 2 can be divided by 1 and 2 only. 3, the same thing, 5, 7, 11. So we're going to write that algorithm to see how we can check to see if A is prime or not. So let's go ahead and start writing the algorithm. As usual, we are going to start with start. So line 2, because we have to divide repeatedly the number by any number between 2 and 1 less than the number, we have to go through a loop. Let's call it index. Index is equal to 2. Remember, we start from 2 to 1 less than the number. So we start with n index equal to 2. Then the next line, we are going to say if index is less than or equal to n minus 1, following the bedmass there, we are going to check to see if it's divisible by index. The number is divisible by index. If it is, then we are going to return false. The number is not prime. Otherwise, we are going to continue with the loop. So we are going to say if remainder of n and index is equal to 0, meaning it's divisible, then I'm going to return false. This means that the number is not divisible, is not a prime number. So, and if, now after the check, if I am not returning false, then I have to increment index by 1. And I have to go back to the beginning of the loop. So go to the beginning of the loop is line 3. And now I'm going to end the loop with an if. When I get outside the loop, then I know it's not divisible by any number between 2 and 1 less than the number, so I know it's a prime number. Return true. And then n. So again, we said we are going to start from 2 to 1 less than the number, and we are going to check to see if the number is divisible by index. If it is, then we are going to return false. Otherwise, we are going to go to the next number and check this one again. And when we get out of the loop, I know that the number is not divisible by anything between 2 and 1 less than the number, so we know it's a prime number. Let's try to test this one with an example. Let's say n is equal to 7. If n is equal to 7, going back here, index at the beginning becomes 2, so I'm going to write index is equal to 2. Then I say if index is, which is 2, is less than or equal n minus 1. N is 7, so 7 minus 1 is 6. So 2 is less than or equal to 6, correct? Then I'm going to say if remainder of n is 7 divided by 2. 7 divided by 2 is 3.5. The remainder is not 0. So this is not true, it comes here. So index becomes 3. Index plus 1. Then we go back here. Is 3 less than or equal to 6? Yes. Is 7 and is 7 divisible by 3? No. So I'm going to go down and I'm going to increment index. So index becomes 4. Then I go back top. Here is 4 less than or equal to 6. Yes. Is remainder of n 7 and 4 equal to 0? No. So I'm going to increment index again. So index becomes 5. I go back here again. Is 5 less than or equal to 6? Yes, it is less. Is 7 divisible by 5? The answer is no. So I go and increment index again. So index becomes 6. Then I go back again. Is 6 less than or equal to 6? Yes, it is. Is remainder of 7 divided by 6 0? No. So index is incremented again. Index becomes 7. Now it goes back here. Is 7 less than or equal to 6? No. It comes out of the loop and returns true. And this is true because 7 is a prime number.